Hello there, everybody. So we're going to keep talking about factoring trinomials here. But what if the a value is not 1? Well, before we get into more challenging problems, we're just going to do these first two. So when we're factoring, no matter what, we have to first look for a greatest common factor. So here, the a value is 7, because remember a quadratic is ax squared plus bx plus c. So the a value is 7, which is not 1. So we can't just jump straight to what multiplies to give me 42 adds to give me 35. It's going to be a little bit more that we got to do. All right, now we have to look for a greatest common factor. So remember, the greatest common factor is the biggest number that they share and the biggest number of variables that they share. So the last term, 42, does not have any variables, so I cannot factor out a variable. All right, but I see a 7, I see a 35, and I see a 42. 7, 35, and 42. 7 goes into each of those. So if I factor out a 7, I'm going to be left with x squared plus 5x plus 6. Okay, x squared plus 5x plus 6. Now I'm going to look at what's remaining and see if I can factor that further. All right, so what is going to multiply to give me 6, but add to give me 5? Because remember, this is going to factor, the first two terms need to multiply to give me x squared, so those are going to be x times x. The last two terms need to multiply to give me 6, so these need to multiply to give me 6, and the inners and the outers need to combine to give me 5x. So what is going to multiply to give me 6, but add to give me 3? So we can check these. We've got 1 and 6 and 2 and 3. Which one of these factor combinations multiply to give me 6 and add to give me 5? 2 and 3. So this is going to be x plus 2 and x plus 3. All right, the inners are 2x, the outers are 3x. So 2x plus 3x is 5x, and 2 times 3 is 6. X times x is x squared. So everything checks out. The only thing I need to remember is that at the very beginning, we factored out a 7. So I need to make sure that I remember to factor or to include that GCF in my final answer. So my final answer is 7 times x plus 2 times x plus 3. So that is the final factored form here. Factored out the greatest common factor, and then we could factor that trinomial further, so we needed to. All right, what about number 2? We got negative 4x to the third minus 24x squared minus 32x. So before we even try to start to factor, first off, this isn't a quadratic, so I cannot jump straight to these parentheses. Instead, we need to look for a greatest common factor. Well, the first thing we see is negative, so I need to factor out a negative. Then we've got 4, 24, and 32. Well, 4 goes into each of those. And then we have x to the third, so that has 3 x's to give, x squared, that has 2 x's to give, and x, which just has 1 x to give. So each of them has an x in common, so I can factor out an x. What's going to be left over after I factor out negative 4x? I'm going to be left with x squared plus 6x plus 8. All right, now we look at what's left over and we say, okay, the greatest common factor is coming along for the ride. Now let's see if we can factor this quadratic further. So the first two terms need to multiply to x squared, so that's going to be x and x, because x times x is x squared. The last two terms need to multiply to 8, and the inners and the outers need to add or combine to give me 6. So what multiplies to give me 8, adds to give me 6? Well, we could do 1 and 8, 2 and 4. That's about it. So which one of these multiplies to 8 and adds to 6? That'd be 2 and 4. So this is going to look like x plus 2 times x plus 4. All right, now we can check this. Inners and outers, 2x and 4x. 2x plus 4x gives me 6x. And then x times x is x squared. 2 times 4 is 8. So that's how I know this works. Okay, so this is the last lesson we're going to do. We're not going to go on to the next direction or the next examples yet because those are a little bit more difficult. We're going to do those together. All right, but for right now, I wanted to go over these two. That way you could do some more practice problems where GCF is involved. So you have to factor out the greatest common factor first. Ask yourself, is there a greatest common factor? And then after you factor out the greatest common factor, look at what's left over and ask yourself, can I factor this further? If you're left with a quadratic trinomial, you want to see, can I factor this further? All right, make sure you do some more practice problems.